My name is Zhong Lin Wang from Georgia Tech. I'd like to give a short lecture on piezophotonics, maybe a terminology you rarely hear about it. In our research in the last few years, we have created a number of fields called piezophotonics, piezophotonics, and piezophotonics. What is this about? Use a piezoelectric effect for photonic purposes. This idea came in as discussed is coupling between semiconductor, piezoelectric, and photonic excitation. These three problems together. Some materials do exist this three problems. For example, gallium nitride, zinc oxide. And the coupling between piezoelectricity and photon excitation is called piezophotonic effect. And this effect was realized just recently. And what it's about? It uses piezoelectric generated field excited photon emissions. The sample we start with is zinc sulfide particles. For zinc sulfide nanoparticles, when it's small, it has a Wuzhan structure, it has piezoelectricity. And this zinc sulfide particle is doped with magnesium. So therefore, make it in a polymer into a composite. No electric wire are connected. It's just a thin film. And you press this film. You press this film, you have light emission. And the light intensity increases with the force you apply here. Force applied. With the increased force, the emission intensity increases, but no shift in wavelength. We increase the force, the emission intensity also increases, but they have a critical value here. And this is the intensity emission as the pressure applied. You can see this is aspheric film, no wires attached. Then use the pencil or pen to write on anything scrub on the surface here. You have light emission. Light emission can directly display on monitor here, so it can record the graphics you wrote. You see the graphics you wrote here? Because the emission intensity is proportional to the force you apply. So this can record the way you write these letters. Not only record the graphics, but also record the speed and the pressure you apply when you write these characters, which is a unique advantage for this. Why do we have photon emission on the excitation of this mechanical agitation? Well, we suggest a mechanism. If you have a zinc sulfide particle here, which is doped with magnesium, they have the doping states. This is the point defect doping here, doping states. This doping states introduce some of these defect states in the conduction and valence band. If you apply a mechanical strain, piezoelectric charge appears across nanoparticle. That piezo charge, let's say negative here, positive here, produce a field which can tilt the band, the conduction band and the valence band being tilted to some angle. In such a case, now if you have the electrons that be trapped by the surface states or defect states, or those defect states can be detrapped to vacuum states here, then the detrapped electron can fall in the whole state, give you additional energy. But this additional energy does not emit as photons. Instead, this is energy being absorbed by the doped elements of magnesium. Excite electron from A state to T state. Excite electron A state. But this electron can fall back to the A state, give you orange color emission. So if you increase the force applied, you increase the piezo charge here, you increase the degree at which the band being tilted. You increase the popularity of the detrapped electrons. So more electrons, more energy released, each one is a quantum excitation, give you orange light. More energy here, give you more photon excitation, but at the same wavelength. That's why you see the increase in the orange color as we saw here. So this is we suggest as a basic mechanism of the piezophotonics. Here, utilize this one, you can record the graphics you sign later. You can also record the force or pressure you use to apply this one. This is very unique. You can be able to do high resolution, personality recognized signature, utilize this piezophotonic effect, and which can have some interesting application for some purposes here. So this is the piezophotonic effect. The first time we realized the piezophotonic effect was in the review we wrote in 2008. That time, in a paragraph, I wrote, the trapped charge can drop from the valence surface state back to the valence band, possibly resulting in photon emission. This process is proposed as the piezoelectric induced photon emission effect, piezophotonic effect, until 2014 and 2015. The first observation was done by the Jianhua Hall at Hong Kong, and also laid out by our group in the Beijing Institute of Nano Energy Nano System. And those papers prove that this effect, it does exist. It's called the piezophotonic effect, and more study remain in the future. So, summarize, again, review the areas here. This is the piezophotonic coupling between piezoelectricity and photon excitation. Piezoelectricity induced photon excitation can be a new and interesting field which remain to be studied in the future. Thank you very much.